Students, welcome back to our YouTube channel. It's Teacher Martin, and today we're going to look at question 7, a question involving Ohm's law. Ohm's law states that the voltage across a conductor is directly proportional to current flowing through the conductor when other factors such as temperature and pressure are kept constant. So we are going to look at a circuit composing of two resistors, and these resistors are connected in series. As you can see, they are connected with wires. I'm going to draw this diagram very fast, and we're going to answer questions involving this circuit. So as you can see, there are two resistors. The first one is the 3 ohm resistor and the 5 ohm resistor, and also we have a source of voltage that is giving us 10 volts. So we are going to look at mechanisms of calculating the resistance when the resistors are connected in series. Also, we may have a case where the resistors are connected in parallel. We also have another mechanism that we use to calculate the total resistance, but in this case we are going to look at this case where the resistors are connected in series. So the question reads, in the circuit shown above, determine the total resistance. You're going to look at the total resistance, and this one is based on the voltage or the potential difference across these two resistors. This one is going to give us the total resistance. The second part of the question is to calculate the total current. Remember, when they are connected in series, the current passing through the circuit is the same. However, when the resistors are connected in parallel, the current is shared between the number of resistors present in that particular circuit. Also, we are going to look at the voltage across each resistors. We have two resistors. For resistors connected in series, the potential difference given is shared among the present resistors. So in this case, the 10 volts is going to be shared based on the degree of resistance offered by these two resistors. So we are going to have a proportion of voltage in the across the 3 ohm resistor, and another portion of resistance across the 5 ohm resistor, and the sum of those proportions gives us the 10 voltage. So we are going to look at the solution of this question. In the circuit shown above, the 3 ohm resistor and the 5 ohm resistor are connected in series. This one is evident. As you can see, we have the 3 ohm and the 50 ohm resistor connected in series. We use the aspect of voltage. We know that the total voltage, which is 10 volts, is given by the sum of these individual voltages across the 3 ohm and the 5 ohm. And also from Ohm's law, we know that voltage is given by current times resistance, and because we have said current is the same, we can factor current out and we remain with resistance only, meaning that the total resistance, which is RT, is given by the sum of individual resistances, which is 3 ohm and 5 ohm. So let 3 ohm be R1 and 5 ohm be R2. Substituting these values, we get the total resistance is 3 ohm plus 5 ohm, and this will give us 8 ohms. So we are done with the first part of the question. Let us look at the second part of the question that involves calculating the total current. So in this case, as we have said, current is the same. Current passing through this circuit is the same, meaning we calculate the total current based on Ohm's law, which states that voltage is equals to current times the resistance. And if we rearrange this equation, we get that the total current is given by voltage. In this case, we have 10 volts divided by the total resistance, and the total resistance, we have calculated it to be 8 ohms. So RT is the total resistance in this case, which is 8 ohms. And if we substitute these values to this equation, we get our current, the total current, to be 10 volts divided by 8 ohms. Remember, 10 volts is the total voltage across the circuit, and 8 ohms is the total resistance of the whole of this circuit. and if we type these values in the calculator, we will get 1.25 volts per ohm, and this is current. So the current is 1.25 amperes. So 1.25 amperes is the current that is passing across this whole circuit. It's not shared, it's the same current. So we are done with the second part of the question. Also, let us look at the third part of the question, voltage across each resistor. As we have said, the voltage is shared. The 10 volts we are given is shared, but it is shared in terms of proportions as denoted by the different resistors we have. So 3 ohm resistor will have a different value of voltage passing through it, and also 5 ohm will have the remaining portion of resistance the remaining portion of voltage that is going to pass through the resistor. So because the two resistors are connected in series, the current flowing through them is the same, that is 1.25 amperes. That's one I've explained. So, and also remember, voltage is given by current times the resistance based on Ohm's law. So we have current as 1.25, and the resistance for a specific type of resistor we multiply by the value. So for a 3 ohm, voltage across the 3 ohm resistor is given by current times resistance, and the current is 1.25, the current passing through the circuit, times the resistance, which is 3 ohms. So if we substitute these values, we will get voltage is equals to 1.25 amperes times 3 ohms, and this one will give us 3.75 volts. So we can easily get the voltage across the 5 ohm, and one of the simplest ways is to subtract, because we said this voltage is shared across the 3 ohm and the 5 ohm. So to get the remaining the voltage across the 5 ohm, we can subtract this voltage, the total voltage, you subtract the voltage across the 3 ohm resistor, and if we subtract, we get 6.25. But let us use the correct procedure, just like we have calculated the voltage across the 3 ohm resistor. We also apply the same formula. So voltage across the 5 ohm resistor will be equal to current, which is 1.25 amperes times 5 ohms, and we get 6.25 volts. So if we add 6.25 volts plus 3.75 volts, we get 10 volts. So in this circuit, the total resistance is 3 ohm plus 5 ohm, because they are connected in series, we get 8 ohms, and the total current, we base this formula, we get 1.25 amperes. The voltage across the 3 ohm is 3.75, and the voltage across the 5 ohm is 6.25 volts. Thank you for participating throughout this video. Make sure you like, comment, and subscribe to our channel so that we can grow our audience base, and also you go back and watch the previous videos so that we can move in the same direction.